Welcome. In this particular video, we'll be completing the square part 1. Let's take a look at our first example. Find the value of c that completes the square. Then, rewrite the expression as a perfect square. So here we have x squared plus 24x plus c. Notice that we have the expression in the form ax squared plus bx plus c. So we can go ahead and identify the values for a, for b, and eventually for c as well. Notice that here we have an implicit 1. So we have that a is equal to 1. We also have that b is equal to 24. And the value of c that will complete the square will be b over 2 quantity square. So we take the value of b, which is 24. We're going to divide by 2 and we're going to square that. And notice that 24 divided by 2 is equal to 12. So we have 12 squared. So this implies that c is equal to 144 because that's 12 times 12, which was 12 squared. So we can say, therefore, the value of c that completes the square is equal to 144. Now, since we already have that c is equal to 144, we can complete this particular expression. So we can say that we have x squared plus 24x plus 144. And we want to rewrite this as a perfect square because we just completed the square. So here we can actually use the diamond method by multiplying a times c and writing the value for b here. And a times c is 1 times 144, so it's 144. And your value for b is 24. So we want factors of 144 that add up to 24. And yes, indeed, those values happen to be 12 and 12 because 12 times 12 is 144 and 12 plus 12 gives you 24. So this can now be written as x plus 12 times x plus 12. And rewriting this in terms of properties of exponents, this is x plus 12 quantity square. So we can say, therefore, x squared plus 24x plus 144 is equal to x plus 12 quantity square. Let's see one more example here. Find the value of c that completes the square, then rewrite the expression as a perfect square. Once again, we have an expression of the form ax squared plus bx plus c. Let's go ahead and do some matching so we can identify the values for a and b and eventually for c as well. Now notice here that there's an implicit 1 as the coefficient of the quadratic term, so we can say that a is equal to 1, b is equal to negative 22, and c is equal to b over 2 quantity square. So that is going to be negative 22 over 2 quantity square. And notice that negative 22 over 2 is negative 11, and we square that, so we can say that c is equal to 121 because negative 11 times negative 11 will give you 121. So we can conclude partially the following. The value of c that completes the square is c equals 121. And this can allow us to now rewrite the original expression as follows. We have x squared minus 22x plus 121. And we want to rewrite now this one as a perfect square. So using the diamond method, we can multiply a times c, and we can rewrite the value for b here. So a here is 1, and c is 121. So we have 1 times 121 will give you 121. And your value for b, or the coefficient of your linear term, is negative 22. So we're looking for factors of 121 that add up to negative 22. And yes, those are negative 11 and negative 11. Because negative 11 times negative 11 will give you 121, and negative 11 plus negative 11 will give you negative 22. So this now becomes x minus 11 times x minus 11. Or using the properties of exponents, it's simply x minus 11 quantity square. So we can say, therefore, x squared minus 22x plus 121 is equal to x minus 11 quantity square. And this concludes our video on completing the square part 1. Thank you for watching and have a wonderful day.